Alright guys, welcome to RC Mojo. Last week we deboxed the Tamiya 1850L, which can only mean this week we're going to start the build. We'll run through the first step in the build in almost excruciating detail to hopefully help any first timers. Then from step 2 onwards we're going to pick up the pace. We start with the info on the other bits we need for the kit. For the tools we need the usual small hand tools, a couple of screwdrivers, some side cutters, pliers come in useful a bit further in too, along with a craft knife. Before we get to the parts, there's the accessory bag to look at. There's a tuber thread lock in there, lots of strips of double-sided tape and foam, a small tube of ceramic grease, which surprisingly is more than enough for the whole kit, the standard Tamiya cross wrench, an Allen key, and a very short linkage, which I think would go between the steering and the indicator mechanical switch on the old Tamiya electronics. To make the build easier, I like to use some plastic pots to tip the screws and small bits into. These are just microwave steam pudding pots, nothing special. They just make it easier to find the bits and keep them safe so they don't roll off the bench. The main parts bags for the sections of the build are marked with a single letter. The kit starts with bag A for section A. However, unlike some Tamiya kits, we also have another set of bags marked BA, BB and BC. These bags only contain screws and nuts separated out, so they're fairly easy to find. We need to tip these bags into some pots, and to make sure we know which is which, we can carefully peel back a bit of the label with the bag ID. As long as you tease the label off very carefully, you can re-stick it to the pot. It should stay put long enough for the build, and of course failing that you can just write on the pot with a felt tip pen. For step 1 we'll need one of the servos. These are just your fairly basic standard size servos. The only luxury part is they've got a ball raced output. Always a good idea if you want them to last as long as possible. On to bag A then, and inside we have a couple of other small bags along with a bunch of metal bits. There's the damper mounts, the shackle mount for the front axle, the drag link with its rod ends, and there's a couple of bushings. In the small bags we have the screws and ball ends peculiar to section A, along with a spline shaft and some other little bits and bobs. We'll tip these two bags into another pair of pots to keep the parts nice and safe. So just to the right of the camera we've got the 3 screw pots labelled and ready to go, the 2 bag A pots, and along the side of the manual I've laid out the bits that are too big for the pots for easy access. Now if you've built a Tamiya before, you should be familiar with all this. Down the left hand side there's a list of metal parts that we're going to need for each step. Every so often they like to hide one in the main diagram, but for the most part they're really clear and easy to use. The diagrams are even 1:1 scale, so you can size up all your parts. So from bag A we need a 5mm ball end, 3 3x10 washer head self tappers, and a 2.6x10 self tapper. From bag BA we need a plain M3 nut. From BB there's a 3x10 self tapper, and from BC we have a 3x8 self tapper. Plastic parts can be a little trickier to track down. Rather than a nice list, you have to carefully check the diagram to find all the bits. Sometimes on the more complex diagrams one might get missed. One good thing though, where a step of the build is broken down into 2 sub-steps, it does make it easy to pick out just the bits for that particular sub-step. So in the case of the steering servo, first we build up the servo saver, then we'll mount it to the mount. To start the servo saver, we need one of the bosses that fits over the servo splines. We have a choice of E13 for Futaba Tamiya or E5 for Sanwa Acoms. Unfortunately, Tamiya don't supply one to fit high-tech servos, which does limit the list of high-quality but fairly cheap servos. But in the case of the Allturn AS700s we've got here, they have the same spline as Futaba. The servo saver assembly then has an E1, which is the spring, E11, the horn, and an E2, a plastic washer. When you're looking for the parts, each parts tree has a letter stamped on it somewhere, so we're taking these bits from the E tree. The parts themselves have a number next to them. When removing them from the tree, use some side cutters and try and cut the parts away as cleanly as you can. If there's still a bit of a rough nub, you can always shave it down with a knife. Now before we start jamming the parts together, we need to know that the servo's in its center position. The servo will follow the position of the stick or wheel. Now usually they will have been tested at the factory, which more often than not leaves them in the right position. But it's a fair bit of faff to remove the servo saver and reset the position if it's not. You can connect the servo to your receiver, plug in an ESC and a battery, then use the transmitter to center the servo, which is the way it's usually done. But if you're fiddling with servos a lot, a servo tester is definitely the way to go. Now a super basic one will do, or a more advanced one will do even better. For setting up the servos, instead of having to rig up all the electronics, all we do is plug in the servo and apply some power. The servo is now locked in position, so we can put the servo saver together without worrying about the position. This particular servo tester is my own design. More information at 74hc.co.uk. Unfortunately, I can't really make them in any sort of quantity due to lack of LCDs. But if you send me an email, I will generally do my best to sort you out. There are of course lots of other servo testers about. There's even a couple with a huge great colour display that can drive several servos. Whatever you end up doing, if you build a lot of kits, a servo tester is really handy. Anyway, the build. First we pop the boss onto the servo. Now it needs to have the lug facing downwards when you hold the servo horizontally, just as the diagram. There's a good chance it's not going to quite sit perfectly. The idea is to find a position that's as close as possible. It'll tend to go to either one side or the other when you're locating it on the splines. Next on is the spring, which just stretches over the lug on the boss, followed by the arm, which has another lug that slots into the spring. And last in the stack is the plastic washer. Now it's there, so when we fit the screw, it leaves just a little bit of clearance so the servo saver can save the servo without binding. Now that lot stacked up on the servo, we need a screw to hold it all together. But the little screw that comes with the servo is only 4 or 5 millimeters long, which is way too short to reach. Tamiya though have thought of that. The 2.6 by 10 and the 3 by 10 self-tappers are there to hold the servo saver together. You need to be careful to get the right one though. Some servos have a large hole, some have a small one. Now Tamiya suggests which to use, but it's safer to hold the screw up to the one that comes with the servo and match the size. However, if you're running a metal gear servo, the self-tappers aren't going to fit at all, so you'll be on your own. Normally an M2.5 by 10 or an M3 by 10 will do the trick. So now we've got the servo saver on, except for the ball end, we're going to take it all apart again and replace it with a straight servo arm. I've found, along with most other 1/14 owners, that the stock servo saver makes the steering quite a bit more wayward than it really needs to be. Even on an indoor layout, when you've got a lot of weight over the front axle, the servo saver really struggles to hold centre. It's better just to use a straight servo arm. It doesn't even need to be a chunky one, although they do look a bit better. Just one of the arms that comes with the servo will do the job. We can pull the servo saver off and pop all the bits into a pot that we will use for the unused bits pot, and we'll press on a single-ended arm. We need to drill out one of the holes in the arm so it's as close as possible to the same distance from the centre as the servo saver. It doesn't matter if it's a little bit different, just get the closest one, drill it out so you can screw in the M3 thread on the ball end, and if you've got an M3 tap, drill to 2.5mm and tap to M3, otherwise drill to 2.8 or 3mm. This time we can use the little screw that came with the servo to hold the arm on. We just thread that in, being very careful not to over tighten it and strip out the plastic. Then the ball end screws into the hole that we drilled, and we pop the M3 nut on the back and really clamp it in. So there we go then, that's the steering servo setup. It was a bit convoluted assembly-wise, but I think it's a good example of following the instructions, but also a good example of where sometimes it's better to do some little tweaks during the build. And that's only half of step 1. We still need to attach the servo to its mounting plate. We've already got the screws out, but we also need to get 2 servo posts, C4s, and the servo plate, F5. On one side of the mounting plate there's a square and rectangular recess. The post that goes into the square recess uses the 3x8 self-tapper. Now the post locks into the recess quite nicely, so if you press down a bit it makes it quite easy to install. So the post can level itself under the servo, we need to tighten it just so it can still move just a little. Same goes for the other post, except this time we use one of the washer head screws. We need to tighten it so the post can still just about slide up and down in its slot. Now we can drop the servo in and install the last 2 washer head screws. Again, we want to install them so they're not quite tight. We want all the assembly to be able to still move about, so we can make sure all the parts are nicely settled in just the right positions. Then, while gently squeezing up the parts, we can tighten all the screws so everything's nice and solid. If you don't build it the right way, you might have one of the servo posts just slightly twisted, which then means the lug on the servo is going to be stressed, being bent by its screw, which would then end up leading to the lug possibly snapping off. If you take your time and build everything straight and square, the model will last a long time and be hassle-free down the road. So that was step 1 with some extra detail. Now we're on to step 2, the shift servo, where we're going to hit more of a normal pace. So for screws from bag A, we need a 2.6 by 16 self-tapper, 3 3x8 washer head self-tappers, a 3 by 15 self-tapper, a 4mm ball end, and from bag BB we have a single M2 plain nut. For plastic we need the bits to make up the servo saver first. We'll need the E12 Futaba Boss, E1 the spring, E7 the base for the adjustable arm, E6 the arm itself, and E2 the plastic washer. Now you may be thinking, why is he building a servo saver when he's just replaced the last one with a solid arm? Well, for the gear shift, the servo saver really is very helpful. When shifting gears, the clutches in the gearbox quite often don't quite line up. Now you really don't want the servo to be stressing with all its power, forcing the clutches against each other when they really don't want to go. The servo saver softens things up, giving a nice, fairly even pressure until the clutches slot into place. The build then is similar to the steering servo saver. We centre up the servo on a servo tester, pop the boss on the splines, being careful to get the lug in the right angle. Next is the spring, followed by the base for the arm. This time though, because the arm is an adjustable length one, there's an extra step. Before we fit the arm, we might as well fit the ball end and its nut while we've got easy access. The nut has a hex-shaped hole, so there's very little faffing about. Now if you're using a basic radio without any endpoints, so something like the old stick radios Tamiya used to recommend, you still need to set up how far the rod goes in and out of the gearbox to change gear. Now that's done by carefully setting the position of the arm on the base, changing its effective length. These days though, almost all radios have an adjustment for endpoints, so we can get away with popping the arm in its mid position and just leaving it there. We just need to pop the plastic washer in and use an appropriate screw. In this case, it's the 2.6 by 16 self-tapper. The second part of step 2 is the servo mount. Now it's in 2 parts. We've got F9, the small adjustable bit, and F8, the big bit. Now just like step 1, we need to assemble it and make sure everything can slide and move until it's all settled in position. The 2 plastic bits are held together with one of the washer head screws. Then the servo offers up and has the last 2 washer head screws to attach it. Once it's all together, we can square it up and nip up the screws. So that's the 2 servos ready to fit to the chassis. But I think that's going to have to do us for this week. We've got a good idea how to use the manual and some ideas on things to think about while building. From here on, we can really get stuck in and make some good progress in each video. So, as always, thanks for watching. Like if you liked, subscribe if you haven't, and leave a comment if there's something on your mind. Bye guys!